So greetings to everyone here, or good evening. We are, or good morning, wherever you are in the world. We're, I don't know, we're the group that I call Team ELIZA, and you'll see all of us listed here. Although I think we're missing one of our members. We're missing Peter on today's call, I think. But we've been working on ELIZA's code for a while. We've got a book project underway. And one more thing I just want to mention is we are going to start off by just showing how ELIZA works very quickly. And I do want to give one more thanks out to Caroline Jones, who's the reason that we're here. She's the one who put us in touch with Magnus. And so gratitude for her. So let me just move on to a quick demonstration of ELIZA. Again, although I know most of the people here know it. And this is a version that was recreated by one of our members, by Anthony Hay. And it has it's written in C++, and it has probably the most faithful adaptation of ELIZA out there. Now, I could have the most famous conversation with this ELIZA, but if it's all right, I think I'm going to have another conversation that we found in the archives, which actually is not written on the same doctor script that we have. So you'll see that it will not react quite the way our archival version has. So let's see, this conversation begins, "Doctor, I have terrible news." And again, we have this in mimeograph form from the archives. "You say you have terrible news." Okay. Yes. There is, got to type a little better than that. Yes. There is a computer program at MIT that'll ruin us. And so in his version, it says, in the mimeograph version, it says, "Why do you say that?" Which again is another sign that we have it's not running the same script. Why do you say that? I have seen it working. Oh, I think we've stopped our run. Hold on. Have I disconnected? Okay, anyway. So this conversation continues, and I don't have it to go on the screen right now, but just for a moment to share it with you. It goes, "You say that you've seen it working. It's frightening. You must see it. You think I must see it? It listens to patients' chatter just as you and I listen. You think I and you listen? No, not usually. No need to get nasty, though. Why do you say that? Someone might hear us. Don't you care? You think I care? You sound depressed to me," says the patient to the doctor. "In your fantasy, perhaps we sound depressed to each other." Anyway, I'll leave it there. It's really a remarkable conversation. You imagine Joseph Weizenbaum having, in a ventriloquist kind of way with himself, I guess. Anyway, I find all these transcripts fascinating.
Mark, you stopped sharing your screen.
Yes, yeah, I know. I'm going back to the slides now, though, because So we are a group assembled because we had the good fortune of going from just having the slip documentation to having the code. And it was originally shared over Zoom by Miles Crowley over at MIT Archives with Jeff. And we brought this into, and then later Peggy and I went and saw it in person. We saw the Holy Scrolls and rolled them out for ourselves to see it. And we are approaching this using the methods of critical code studies, which is a field that I've helped to start, which does sort of archaeological readings of culture through code. And now a lot of this code, by the way of the ELIZA that we have found, has now been digitized and put online, so you could access it through the archives. And that's just a very short introduction, and let me pass things over to David.
Hello all. Next slide, please, Mark. So I just want to give you some sense of the kind of questions we're thinking about and looking at. I mean, one of the kind of problematics is that, of course, back in the 60s, people didn't realize the ephemerality, I think, of the artifacts they were working with, and I think ELIZA is a good example of this. And so what seems pretty clear to us, at least in relation to ELIZA, is that the kind of versioning systems that we're very familiar with today were not used. So version control was weak, to say the least. And in addition to this, in terms of backups and printouts, certainly these were often seen as disposable media. It's a classic when you work with computer archives that a lot of the paper that was printed on would be thrown away, and of course it was quite cheap paper anyway, so it didn't feel like an important piece of archival history for computer scientists, and it's a great shame. And so one of the things that we've certainly found in the archives is that there aren't the things in the archives we wish there were. And of course, the fact that anything is in the archives is really an accident, I think. So ELIZA does not have explicit version numbers, but what we have done is try to reconstruct at least some sense of a kind of versioning system to help us to understand what we have, and also what we might also look for, not just in the MIT archives but elsewhere, as we start to move a bit further afar, trying to find other versions of ELIZA. So we think there's probably 5 major versions based on the discussions in different papers published by Weizenbaum and also by Taylor and others. And if I could have the next slide, please, Mark. Thank you. And this is the kind of versioning that we're currently working with, which is that because we now have the source code, that's just moved over. Because we have the source code for one version, version 2 here highlighted in yellow, it gives us a sense of the kind of development timeline that Weizenbaum was working with. So we know there was a version which we call ELIZA 1965A, because there is an MIT archive flowchart which we found, but we don't have the source code for that version. We do have the source code for a version we call ELIZA 1965B, and that's because we can, as it were, use the algorithm described in communications of the ACM in order to be able to understand the decisions made in terms of the functional application of the code. One of the interesting things that Ant has pointed out to us is that it actually lacks the new key function, which is described in the CACM article, but it also delimitates with but, which is not described, if I remember right, in the CACM article. The other thing that's very interesting, quite exciting, I think, in the code that we have is there's an undocumented change function and a series of hard-coded messages. And that's the version we've been working with. And I'll just say very briefly, and I think the others will comment on this as well, but it's kind of a very strange programming language because of the way it compresses words into smaller acronyms. So that means that we do not actually have, we don't think, the version described in the ELIZA CACM article, the 1966 version. We have probably the version just before, and the CACM article describes this new key function and also describes a keyword stack as well. So we think we're close, but we don't actually have the one, as it were. However, we also know from from Weizenbaum's 1967 publication and Taylor's 1968 a description of a different version of ELIZA, which we can call ELIZA 1967. This has much more sophisticated script handling, and we also think because of these other scripts that we found in the archive that they point to a different version. And lastly, Taylor in 1968 also describes what we're calling the ELIZA 1968 version, 1968 plus version, is a very sophisticated version of ELIZA, which is kind of far beyond the one that was originally described in 1966 in terms of its functionality to scripts. Can I have the next slide, please, Mark? Thank you. So one of the very exciting things that has come out of the archival work we've done, though, is that we now know there are a rather large, I think it's 30 different scripts we've now discovered in the archives, many of them undocumented before, We have some of the code for these scripts. So we have a rhythm, F29, and so on and so forth, and girl, for example. So we have some of these scripts, some of which would have worked on the 1966 version, some of which won't, because they rely on functionality that's not there. Thanks, Mark, for the prompt. And there are also scripts that we have output for, but unfortunately, rather strangely, the scripts themselves were not stored by Weizenbaum. So you obviously thought the outputs were good, but not the code itself. And then lastly, we do have listings for scripts that are either referred to, or they're literally just directories of files that Weizenbaum has accidentally included, and we can see those other scripts listed. And you can see there at the end, there's a list of some of those. And some of those we know what they do, and some of them we don't know what we do. And the one that I think is quite interesting is in the center there, SPAX. SPAX is actually a script to teach poetry, the poetry of Barry Spacks, actually, who was in the MIT Humanities Department. So that's kind of interesting to see the different ways ELIZA was being used. And of course, teaching was one of the things that Weizenbaum thought ELIZA might be useful for. Okay, I pass it over.
Jeff? Yeah, you want to go to my first slide, Mark, please? That's the wrong way, I think. There you go. Oh, back one. Back one. Thank you. Okay, so I'm Jeff Schrager. I have been part of the, first of all, I have to admit, I have no idea. I only barely know what problematics means. I have no idea what the word hermeneutics means. I've been part of the AI, maybe I should. I've been part of the AI intelligentsia since I was 13, when I wrote in BASIC a version of ELIZA, which it turned out was published in Creative Computing. And if you squint, you can see my name in the comment field at the beginning of that code in 1977, which was utterly fortuitous in the positive sense, because as somebody pointed out earlier, Patrick, I think that it was the explosion of the PC era. And essentially previous to that, ELIZA had only been written, people thought it was written in Lisp. The only version they had was an internet academic version written in Lisp. Nobody could read Lisp outside of academics. Nobody had computers outside of academics. After this period, basically everybody had a basic computer running on their desk. Well, everybody, who could afford one, which wasn't very expensive or cared. And so since Creative Computing published this, it became one of the most popular games, and in fact became one of this program, I'm embarrassed to say, which was a terrible knockoff of ELIZA. I had never seen the original ELIZA. Became one of the most cloned programs in all of history. I keep getting, to this day, people sending me code that is a knockoff of my basic program through perhaps 6 channels. So next slide, please. So for this reason, as I proceeded in artificial intelligence, I also got involved in molecular biology. I got involved in the genealogy genealogy of ELIZA versions, which was referred a little bit to in what David was talking about in the sort of local sense, but I'm interested in the kind of large sense of, which programs influenced which programs. And before that, in fact, and so I started this site called ELIZAGen, which is partly how this team kind of formed, is because some of them found me and I found some of the others. And one of the problems was that we had the Lisp version from BBC, which we got into the ELIZAGen, and we made work actually in modern Lisp. And then we had the basic version, of course, which sort of everybody had, and David, that's how David and I got connected. And so, but the next slide, please. But the MadSlip version was undiscovered, right? This is at the bottom is McCarthy with his famous beard at the famous 7090 computer, CTSS computer at MIT Project Mac. And on the left is Joseph Weizenbaum at the same computer. It's obviously not really Joseph Weizenbaum, but it is at the same computer, bizarrely. And I've shown just little snippets of the 3 versions of ELIZA, the sort of 3 root versions of the tree, in a sense. The left one is the MadSlip. And you can see a little bit of what David was referring to with the weird abbreviated programs. You can see this much better online now. And then on the right at the bottom, we have the Lisp version. And because nobody had found the Madslip version for the longest time, everybody thought it was written in Lisp. Many people thought it was written in BASIC after 1977. And then my version is in the back there. If people are interested a little more in ELIZAgen in my particular version, which you shouldn't really be because it's terrible, you can. There's a co-recursive is a computer-oriented podcast, and a fellow named Adam Gordon Bell, no relation to Gordon Bell, actually did this podcast sort of focused on the ELIZA story, which is, I think, quite interesting, although I think it focuses on me way too much. Next slide, please. So as I said, from ELIZA forward, I'm, other people more astute than me have tracked the influence of ELIZA. In fact, other folks on the team will talk about that. I've been interested primarily in the technical back history of ELIZA. In other words, where it came from, where its technical influences came from. And I've been building, in fact, I have a paper that describes this, from Hilbert through Turing, through, as it turns out, Newell and Simon were in the sort of club of Turing and the other people addressing the Hilbert paradox, Gödel and Church. And Church, of course, begat lambda calculus begat Lisp. Through McCarthy, Lisp begat the Lisp ELIZA. Well, begat a lot of things, but was necessary for the Lisp ELIZA. And Newell and Simon used IPL5, which I mentioned was the language Feigenbaum used. Feigenbaum met, Weizenbaum. I'm going to get all the Baums mixed up again. Then came SLIP for Feigenbaum for this to replace IPL5 and ELIZA. And there's a lot of interesting history, and I have a paper on this if folks are interested to read a draft, which will go into our book. Next slide, please. And I think that's actually the last slide. Oh no, this is just the last. The right half of that is again talking about the much less detail from my point of view, which is essentially looking at the various technical knockoffs of this. And so if folks are interested in seeing this mind map a little more detail or reading about it, I can give them the thing. And so that's time, I'm told by Mark. Is there another slide? I don't think so. No, perfect.
All right, I guess I speak. My name is Art Schwartz. What I'm going to do is describe something about ELIZA itself. I want you to imagine you have a 16 gigabyte machine, and on that machine, the instructions are 4 bytes and data is 4 bytes. Therefore, you have 4 billion items of instruction and data intermixed. Weizenbaum, in comparison to Weizenbaum's machine, this is 131,000 times the amount of space that Weizenbaum had. If we assume that the response time to be considered an instant response is 250 milliseconds, then on your machine, you can execute 250 million instructions to satisfy this real-time requirement. Weizenbaum's machine only can execute 50,000. We are discussing a piece of code that's 420 lines long, 57 years later. We are analyzing it, describing what it does and how it does it, and it's old, but it's novel. Let me tell you a little bit about the code itself, what it did. It's amazing. Weizenbaum said, let's recognize a keyword. It's pretty simple to do. Then he said, what sentential forms can that keyword be in? In other words, if I have a sentence, where would that keyword be placed? And since a keyword and sentences are multiple, where would the keyword be placed in multiple sentences? Like, I love you. Love is there. I don't know what to love. Love is there again, but there are different sentences. He devised a regular expression, a mechanism to take and parse this input sentence so he can extract significant portions in order to develop an output of dialogue. So we have on the front end the ability to recognize a keyword, to match a keyword with a sentential structure, to extract parts of that sentence to construct an output dialogue. all within 250 milliseconds. But there's more to that. One of the things that is fascinating is that when you talk to a person and ask a question, you get an answer. But if you ask a similar question, you don't get the same answer. For a machine to simulate or parody human speech, it can't respond by giving the same answer for the same question or even similar questions. Furthermore, in human speech, when you talk, often their discussion veers from one direction to another. You ask a question or make a statement, and then a statement not related to your question or statement is uttered by your dialogue respondent. Weizenbaum has to simulate this. So what he did very cleverly is, after he discovers a sentence, he said, well, we have a number of different sentences we can output. Let's not output them all at once. Let's take turns and output each one in turn. Well, that means that if you have a sentence structure and it's repeated 5 times or 6 times, you get the same sentence the 6th time or same response the 6th time as you did the first. Not true. Weizenbaum added another function, in his paper, he calls it a counting variable or a counter called limit. And here, every so often, what we do is we output, just as in human speech, a question or a statement unrelated or casually related to what was just asked. So we're simulating human speech. We go even further than that. Suppose we can't find an answer. We can output something that we remembered from a previous discussion. In a previous discussion, we take and we form something which Weizenbaum calls memory. And in memory, we have a series of rules. And when we see a keyword associated with memory, we recompose or compose a portion of a dialogue or a dialogue and put it into archival storage. And as necessary, we take it out. So what we have is a machine that simulates speech. It talks to you as if it were a person. But there's further, a little bit further. When I say I, the machine doesn't say I, it says you. So I like to say that it's not always talking about you. So what we have is another mechanism that says when a word comes in, maybe we have to change it to another word for our dialogue to work. So I becomes you, mine becomes yours, and so on. We have another mechanism. There's yet another one. This guy is truly inventive, but I have to tell you, I look at regular expressions in sentential parsing as really a significant achievement. That is really something you don't see very often. A regular expression is something that was mentioned in Chomsky's type 3 grammars. It's been used in parsers and scanners, compiler generators for decades, but not at this time. It's truly innovative. Suppose an input sentence has several keywords. Weizenbaum devised a mechanism to pick which one was important. As you've heard Dave say, there's another function called new key. And here, as we have recognized, when we recognize a sentential form, again, to simulate speech, we can say, well, if a sentence has multiple keys, we'll pick another key and analyze the sentence with respect to that. And so now you have another way of separating a deterministic machine from a non-deterministic world. In addition to what Weizenbaum does, what we have done, in particular, Anthony Hay has done, he provided a copy or a simulation of the actual code, which is identical to the actual code. In this regard, he has discovered some things. Dave mentioned one. The CACM paper suggests several delimiters, 2 delimiters, a comma and a period. It turns out that the dialogue in that page that shows ELIZA's input and output contains a word but that is undescribed in the article, and Anthony has found it and described it. As another thing, which wasn't used afterwards, in the initial code that which we have, remember 420 lines, 57 years later, he also provided a mechanism to edit a script. Suppose you're running a script and you say, gee, I don't like that, whatever that is. There's a mode in the original 420 lines that allows you to edit the script, store the script, and rerun the script. You have the ability then to change your mind, to change the way the system reacts to the outside environment, not for a casual user, but for the developers. This is a discovery by Ant. He's done remarkable work on this stuff. Weizenbaum also did something else. Again, this guy is remarkable. He developed a piece of software to handle acyclic graphs. He called it SLIP. That's S-L-I-P. He used that as an application programming interface within his code. So his code is 420 lines. The facility he used to enable him to do work is 1,300 lines. So we're talking about 1,700 lines now. That was developed a couple years prior to the delivery of ELIZA. It was mentioned, I think, in 1964 CM article. And furthermore, that code has functions directly used by ELIZA. In fact, it has a function that does the disassembly, that is the sentential recognition and partitioning into recognizable parts. That is called YMatch. And it has the assembly, the reassembly of a dialogue. And that code is called assembly, ASSMBLY. And I think, if I'm not mistaken, Jeff pointed that out. Jeff Schrager pointed that out. There's more, but my time runneth out. I'd like to thank you.
Hey, Peggy.
Mark?
Oh, okay. Boy, I hate to cut off Art. Thank you, everyone. I want to point out with this photo right here. First of all, thank you, everyone. And I think it's really remarkable and worth noting that at this moment, when all eyes are on speculative AI and the potential dangers or issues, that really we can acknowledge that all, if not most, of the issues surrounding this have their origins in Joseph Weizenbaum's response to his creation, of course, ELIZA. I hardly need to tell this group, and by the way, thank you to everybody in this group, especially the organizers and our team, ELIZA, that he named ELIZA in reference to, a whole series of characters related to the myth of Pygmalion and Galatea. And of course, in those myths, stories, movies, musicals even, the creator falls in love with his creation. And it's a notable switch that in this case, Weizenbaum doesn't actually spurn, his creation, but he takes a much closer look at it, and that this propelled him to change his life. He studied, I think we could go to the next slide, Mark. Yeah, he studied, he changed his life, he went to Stanford, everything that everybody's accounted. I thought you might appreciate that we went back and found his application to the NSF for this grant to go study the humanities in Stanford. And of course, that's when he was working, I believe, with Mumford. He lectured, he spoke to students, and to deliver this message. And this is a note where we talked about the AI intelligentsia as the object, or the, as Jeff said, well, I might be the intelligentsia, but I didn't have my fingers on the button. He also focused a great amount of attention on students, the future finger pushers, or the future potential buttons, the future potential uses of technology. I'm here really not as a coder, but as an artist and somebody who got that message. But we can think of that, maybe we talk about the ELIZA effect. I'm about to talk a little bit about the Barnum effect, but the Weizenbaum effect was to tell as many people as he could to consider the implications of your work. Is that, can you go to the next slide? Next slide. I'm sure most of you who've seen this, who studied, but this is from the film where there's the quote. He says, students come to me with a thesis topic and ask me, can I work on it? And he replies, imagine what the first use of your work will be. Imagine yourself being there with a button. Didn't somebody mention button earlier? In front of you. And if you press the button at the last minute, nothing that was supposed to happen based on your work would happen. If you think you'd press that button, don't work on that project. So I want to bring into the scholarship, the message was to students, perhaps a distant early warning, system for AI and future technology. I was one of those students, but one among many, many, both at MIT, I'm sure across the world, and certainly in Europe. This happened much later in Europe. I was a grad student at MIT, really an artist at ArcMac. Now that's the Media Lab. I heard Patrick Winston, who was teaching Intro to AI. So regardless of what the AI group, the Seymour, Papert, Minsky, people who were distancing themselves from Weizenbaum, Winston brought Weizenbaum to our class to lecture to us. And he delivered a very personal lecture recounting his childhood in the Holocaust and his dismay at it being used, at his work being used for a very, what he considered dehumanizing relationship. Next slide, please. I wanted to jump into on a method. Really, I think this is very important to talk about what I would call the Barnum effect, the ventriloquism effect, that when somebody mentioned magic or a trick, he felt from the very beginning, this paper is 1966, to explain is to explain away. And a huge part of his efforts weren't to diss AI, it wasn't to disparage the work, it wasn't to insult his fellow workers, it was to explain and overcome the ignorance of non-technical people to, or just everybody about to blindly accept everything, to try and understand it more thoroughly. And even in his book, he mentions, I think in the foreword, that you don't have to read maybe the first couple chapters, but he's going to start at the beginning with how a machine works. Okay, 30 seconds to go, next slide. Just to say that I would hope someone would look into Norbert Wiener, who was an influence of his, who also talked about consider the implications of your work, who talked about forming something akin to the Bulletin of Atomic Scientists. And somebody here, mentioned that earlier. And the Computer Professionals for Social Responsibility, of which he was a very early awardee, did consider a very broad array of topics. Of course, that was short-lived and is demised in about, it met its demise in, say, 2013. I'm going to skip my work, and why don't you go on to Sarah? Although I'm about all bots are liars is the Barnum effect. Let's keep going. Let's just go on.
Please talk
Sarah,
about your work, Peggy.
Pardon me?
Please talk about your work, Peggy. Mine will be really fast.
All right, I'll go back. I'll go back one slide. So 15 years later, after hearing this lecture, I created something called the blurring test. It's not a literal reversal of the Turing test. Really, it was reflecting my deep concern that we needed to consider our relationship with machines, to reconsider, to switch our focus from the potential of the machine to our relationship with machines. It was up from 1998 to 2014, and Mr. Mind asks, hi, can you convince me that you're human? That's been turned into a song cycle. Next slide. I wonder what effect I have on you. I have 16 years of transcripts of people telling my computer program what it means to be human. So this was this is the Weizenbaum effect on me, and hopefully people who experience Mr. Mind and perhaps the song cycle. Okay, on to Sarah.
Thank you. And thank you to the organizers. I just wanted to respond sort of directly. Thank you to Christian and Magnus for the prompts that you gave us. In particular, I was really interested in the question that you asked was, Eliza, the first chatbot, and what were the similar programs at the time and examples of related developments before, concurrent, or post. And I think in answering this, it's not to take away from the sort of exceptionalism, the exceptional work that Weizenbaum was doing, but to kind of point to how Weizenbaum is bringing together so many different threads and contexts that he's situated within. So I'll just quickly go over this because it might be a little bit small, but and highlighting here because my research interest is in histories of an alternative context for natural language processing. So there were other chatbots being developed around the same time as ELIZA, but nothing really actually doing what ELIZA was doing. There was work in sort of the question answering area, but they are all very domain specific, subject specific. So you've got Lunar, which was trained to answer questions about moon rocks, or specifically asking questions about shapes or solving algebra word problems, but you don't have anything that is this kind of general, can respond based on having a conversation in the same way that ELIZA does. You've got people working on speech synthesis and speech recognition. You know, we've got this idea of speech machines happening from the 17th century even. We've got speech recognition happening, but on very limited scales. We have a lot happening in machine translation from the late 1940s, particularly with all of the funding from World War II. We were very interested in translation from Russian, and a lot, I'm particularly researching right now the 1949 memo from Warren Weaver, and a lot of like ideas coming up in machine translation end up appearing later in natural language processing. And of course, there's all kinds of developments happening at the same time, people talking about how can we apply ideas from what is becoming artificial intelligence in linguistics and language parsing and cybernetics, but there's nothing really, nobody's doing what Weizenbaum is doing in this way. These are all kind of in the ether and part of the conversation at the same time. Thanks.
Okay, thank you very much, all of you, for giving the presentation. Yes, clapping virtually or like this. Okay, we still have, I think, 20 minutes? 20 minutes time for discussion, for questions, for remarks. Well, I think I have multiple one, I can say. I see Magnus also has one. But of course, like we want first to give you the chance. Okay, if that's not the case, Magnus, then please start with your question first.
So, thank you very much for all the insights. I tried to follow, but of course I could only partially follow. That's why I'm also really looking forward to your book, reading it in advance before it's officially published, and then of course after it's finally in a perfect shape. Then it's published. Of course, there's so many questions now to ask, but I will start with David. One thing that David talked about, and I feel like that so many people are still curious about, and that is scripts of ELIZA that is not doctored. And David, you hinted at this, that you might know that you know what the other scripts do, at least partially, and could maybe you or the team talk about the other scripts, or maybe working scripts. What do they do actually? How do they work? And not how do they work, but what do they do?
You want to take that, David, or should I? Or
Yeah, I was just looking for our list of, there it is, script genealogy. So we've got, I could share this actually, if that's helpful. Let's just take that there. See if I can share, because sometimes, as we all know, mine will not allow me to share. I don't know if one of my colleagues can do it. It's called Script Genealogy in the ELIZA chapter drafts. But meanwhile, if someone tries to find that, in the version we've got, the script genealogy so far, if I just scoot down, we have 27 different scripts. And we have, for some of them, archival examples. So, for example, a rhythm, which takes mathematical calculations within the conversion that is available to evaluate and return the results. That's a script. We have an archival version of it. And I think we also have the output from that, maybe. I'm not sure if we have the output for that one.
David, let me make a high-level general observation before you go through the list of scripts, which might be helpful.
Yeah.
There are roughly two, grossly speaking, completely different versions of ELIZA, completely different application areas of ELIZA. One is the conversational application, and the other is a later, like the next year, he apparently had some students, and we've talked to some of them, educational version of ELIZA, right? And some of the scripts David's talking about are for the conversational version, and some are for the educational version. I think the most interesting thing, David, to show, if you have it, is this. So the version applied to education was much more advanced than the version applied to conversation, because you could actually put code. He had a language called OPL that you could put code in along with the language part of the script. Sort of Art mentioned this in his in passing, that it was a very advanced. Do you happen to have that code snippet that has the code in it?
If someone could open the document that I've just sent to Mark, then he could perhaps, I've actually put the links on each of the code fragments, right, which I don't know if will work live, but you can actually click through to each version of the scripts and the versioning we've got. So that might be quite interesting for people to have a look at. That's interesting. So as you can see, we have quite a few, and if you click on one of the archival photographs, you can see them. So that's actually from the educational version, Taylor 1968, which is the later version of ELIZA. But if you go up a little bit, you can find the ones that we have found. There you go, archival photo. Those are the interesting ones, I think, in the first place.
Could you just briefly describe one or two of those scripts? What do they do?
So they're generally pretty simple. I forget now what a rhythm does. It does I think it does it do sines and cosines? I forget now what that one actually does, but they all have a very simple function. SPACs, I think, is, I don't think we actually have the code for SPACs, unfortunately, but we have the output of the SPACs. You can see the kinds of conversations people would have with the code. Is the SPACs one there? Can you go down there, Mark, and see if it's actually there?
Yeah, we're maxing out my computer with Zoom and Doc, so let me see if I can get there.
But there are some, they are very interesting. I mean, some of them are a sample one. So girl is a very, very simple script just to have a demo conversation. And then some of them are quite sophisticated. I know that Ant was going to try to run some of these on the version of ELIZA we've got. I don't know how far he got with that, but you know, when you run these scripts and they start generating errors in the code we've got already, I think that will be quite interesting, because they may be revealing of different versioning as well.
I think Mark's given up.
It looks like Mark's crashed, unfortunately.
Yeah, it's not.
We can make some of these available for inspection if you want. But the key difference is that the scripts that are for the later ELIZA, the much later ELIZA, the educational version, you have the language part, which looks very similar to the earlier scripts, which are just language interaction, but they have embedded code like calculations and loops and stuff like that, literally embedded in the script. I don't anyway believe that Weizenbaum wrote this version of ELIZA. I believe it was rewritten in Lisp by Walt Daniels, who we talked to, and I can't remember exactly what he said, but so it's actually completely different. No, was it part of the original ELIZA?
Yeah, well, we don't know, unfortunately. Walt told me that he didn't actually rewrite or add functionality to ELIZA. I think that was Taylor. He actually only wrote the scripts on the new version of ELIZA.
Taylor, I'm in the group of Taylor and Daniels. Sorry,
Yeah.
I didn't mean to attribute necessarily to Daniels himself. Right.
Yeah.
These were students of Weizenbaum's who were working on the educational version of it. Well, Taylor wasn't. Taylor ran the physics department, right? Daniels was the student. So it's a very interesting, complicated interaction. But as far as we know, that's as far as ELIZA, the original ELIZA went. Then it, basically rolled off into the Lisp version, which was done by Bernie Kosel at BBN, claiming to have done it off the paper. And then everybody thought it was written in Lisp, and that was sort of the end of the Mad Slip version.
This is specs in case people want to see it.
Oh, that's nice.
And just to one last question, maybe then someone else got one. So those are scripts also written by Joseph Weizenbaum, or is it not known?
Yeah, we don't know the authorship. I kind of feel that Weizenbaum was probably the author of the scripts that we have in his archives, that are in his folders. And so I think it's likely he wrote those scripts. I think an interesting question we could raise is we don't know whether Weizenbaum actually wrote the code for ELIZA itself. We know that in the it's kind of interesting, shall we say, that in the oh, I think my things might have just gone.
Can you still hear me?
Yeah.
My headphones run out of battery. It's interesting that when he's kind of proud of the code, the source code, he includes it in the publication. So the Slip publication actually has the source code in CACM, but the actual ELIZA is just the algorithm and the doctor script, but not the code for ELIZA.
This is a very interesting point. It's not, I don't think it's a matter of proud. Remember, he says in McCorduck's interview, he had to actually, so it wasn't the thing at the time to print code, because code, of course, was long, right? And there was only publication, there was no GitHub. So it was, he had to actually fight with the CACM to get them to publish the slip code, right? So it was not normal to publish code at the time.
It's also interesting that in the with the first algorithm he published, the 5 in a row, he actually references the programmer of his code, who was R.C. Shepardson.
Right.
But he obviously wrote the algorithm, but not the code. Right. And I'm not quite sure what the culture was. I mean, it's kind of, today we have this similar idea that, architects and designers, it's kind of the division between theory and practice and so on and so forth. But I'm not quite sure in MIT to what extent that was happening. I did, before this talk, quickly look over the Project Mac documentation, and they had a very large technical support staff and a lot of research assistants and so forth. So it's conceivable that he would have had help programming.
We could ask Salzer, actually.
Mm.
But I'm pretty sure, he was a software engineer from GE, right? So he definitely, I think, pretty surely wrote Slip, at least, and almost certainly.
No, he wrote Slip. Yeah,
but
that's what I'm saying. Sorry, Art.
I'm sorry. I have interrupted my master's mentors. Anyhow, Jeff, to your point, the CACM did allow code for algorithms only. So if you're writing an algorithm in a Chebyshev, whatever, you could include, in fact, you did include code. It was a version of Algol, if I remember right, originally, and then after a while, Fortran was accepted.
But it is interesting the ones that he chooses to include in his publications and those that he does not.
Right, the
And
slip code.
this is circumstantial evidence.
Yeah.
I would also have a question concerning this that I was asking myself. There's this famous ELIZA conversation in his article from 1964, where he, you know, like this men are all alike. This conversation. I was wondering. I guess like at that time when he published it, the doctor script was the main version of that he used to have this conversation. So I was wondering if you could replicate this, because when I was at the MIT archive, I found two versions of the same article basically.
Right.
And they were only different in one aspect basically, which is this very conversation, like as an example of how a conversation between ELIZA and a user in front of the screen looks like. And he is referring to this conversation as a typical conversation, right? And the other one that was not published in the end is a super boring one, right? So it's one of this like saying something and then basically repeating the answer like as a question. Like it's really boring to read and not impressive. And then this men are all alike conversation, it in comparison is actually quite like impressive.
Well, we have a lot of things to, we have a lot of things to say about that one. And two things we'll note is we've been able to recreate that conversation with, but as a delimiter. Again, not something that's specified in the article. So a period, a comma, and but used as delimiter. And the second thing is one of my favorite observations that Ant made, which is there's this thing that Ant refers to as a certain counting mechanism. I think Weizenbaum also refers to it that way in the article. I can see it looks like I'm breaking up a little bit, but one of the beautiful things about that article is the way that the conversation ends. And there's a list of things that it's gonna use as recall functions at the end. You know, it's gonna bring something up back from conversation. And there's that great sort of closing of the loop that happens. It happens it's because the fourth of these recall functions gets called up, and it's able to sort of like conclude the talk on that beautiful last line. So we have copies of that dialogue that have been edited. You can sort of see that like Weizenbaum is working both halves of this conversation at the same time, you know, making sure that the system can have an interesting conversation, making sure that the conversation is interesting. But it's fascinating to me that the script is perfectly set up to deliver that closing zinger. And it could just as easily not have done that if the person who was having that conversation with it maybe wasn't aware of how it works.
So yeah, I was just wondering, why was he submitting or considering to submit
the weaker
one or the other? And to me, first it was a question of authenticity. Because he's naming it like a typical dialogue, so I was not sure if it is an actual dialogue, but more like of a, you know, like a synthesis of different dialogues or something.
And maybe somebody said, great paper, boring conversation. Can you get a more interesting conversation?
Maybe.
Yeah, I mean, I think the question is, I mean, that the article purports that it's a conversation that somebody had with ELIZA, right? If I remember correctly.
It imputes. I don't think it claims.
So the question is, again, is that a complete fiction? But yeah, arguably that conversation did just as much to promote ELIZA as anything else.
Yeah, that's why I also think it's okay. Yeah, perfect. But perfect. That's a great. That's already great.
Can I just add to that, Christian, and say that you know, if we put that, you know, in its historical context as well, you know, where Weizenbaum is in his career, you know, in terms of like his relationships in Project Mac, etc. You know, it was important for him to produce a winner, and so I don't blame him being very careful with that publication. And, you know, if you read interviews with him, for example, in the New York Times, etc., he is proud of this software. You know, in the 1970s 1968 interview he does in the New York Times, you know, he says that he's actually asked explicitly, well, what's the use of this software? And he says himself, it may conceivably lead to some therapeutic developments or computer teaching machines. So he's the one who's proposing this like instrumental use of this technology. And of course, later, partly because of arguments with Colby and Parry and all that kind of stuff, he starts to get very concerned about this. But nonetheless, early on, I think he's genuinely quite proud of it. And we have to remember that the later Weizenbaum of 1976 is not the same Weizenbaum of 1966.
Well, and I think that's something that Peggy and I in particular sort of seized upon in the McCordick interviews, where he talks about some of the things he's done in the past. There's a great exchange about a computer program that he wrote that would answer a true or false question. And there's this whole write-up about how he would hold at a distance the code for people to see how little code this program worked and try to see if they could guess how it operated. And they couldn't. And there was a little trick in the code where, because he hit backspace before he entered their question, it would answer one way or the other. So again, I think I know it's important that we focus on Weizenbaum, the moral man, that I saw in the archives in the letter he wrote to the telephone company, thanking the operator for helping the little boy contact his mother who was in the hospital. It's important that we remember that person who wrote back to all of those people who wrote to him with positive reactions to computer power and human reason about, you know, thanking them deeply for their concern, is, you know, who was interested in Cambodia and all on out. But I think it's important also to remember this other person who comes up with this clever idea, this clever trick.
Mm-hmm. Okay, so we are already through. Magnus, quick question and quick comment, maybe, or comment. Okay.
And I just like to emphasize what David has said, because I feel like it's often like overseen or forgotten, is that Weizenbaum, most of the time, he would say, Eliza, this was a parody. I wanted to show, you know, how bad or crazy AI people are and so on. And like, very often people buy into like, of course it was a parody and he was just making fun of it. And there might be evidence, of course, if you read the papers before, how to make machines look intelligent. But at the same time, like David, as he has pointed out, he was kind of proud and was talking about
it wasn't a parody at all. I agree. It wasn't a parody at all. It was a tool. It was a tool to study human-computer interaction.
But he does use the word. He does use the word parody in the article, and I think we've had many discussions about this, and again, for my money, where we've sort of landed on is that, yeah, the word parody, as Peggy points out, is unfortunate, and that we're not talking about satirizing Rogerian psychotherapy. I think as much as something that is not as rich as psychotherapy could be from someone who had reaped positive benefits from actual psychotherapy. But yeah, David also mentioned it depends on what definition of parody we use.
That would be the point I would also ask myself. Of course, this was maybe a period of 1.5 to 2 years of developing. So maybe very at the beginning, he was maybe very positive that, you know, but as testing it out, maybe his opinion already changed until he then actually released the paper. So maybe there was also some developing going on, let's say from 64 to 66. Yeah, but this is just hypothesis.
I mean, one of the things that Anthony's been pursuing is this question of, you know, how could people think that this program was a person? And so we've done a lot of excavating and thinking about the hardware interfaces you would have had in connecting with this program, you know, interacting with something over a teletype that seems to be responding. You know, it's not like you're looking at a computer screen or a monitor of any kind. And the second thing is, so I think Weizenbaum could have had the same thoughts that Anthony's having. How could anyone think of this as a real person, let alone pour their hearts out to it?
Okay, yeah, so I
think
think
I'm not sure anybody did think of it as a real person. And I think people thought of it as an effective, but they still felt that they could pour their heart out to it. I mean, there's a difference than claiming that people thought ELIZA was sentient. There's an MIT Press magazine, an MIT I don't know, I guess it's the, whatever it's called, the MIT magazine that I got yesterday. There's a big article on consciousness, and there's a little paragraph where the woman says, oh yes, and he was dismayed that people thought that Eliza was conscious. I don't think anybody, I think that's going too far, and I think that's glossing over it. It was enough that it was being considered to apply technology to dehumanize the relationship that was concerning, not that everybody was so fooled. But that
I
it
know,
could
but
be
look how easy people get
I
fooled by
really, I really
ChatGPT,
have
and
to,
they
I
know how
really
it
have
works.
to stop. I really have to stop this now. Although actually, I mean, I'm now thinking like at the beginning, I was like half an hour is a long time to have a discussion, but it's not. I wish we would have more time for this. Actually, and I still have like 3-4 more questions, but I think I have to write them to all of you. So very, very much thanks for all of you for giving these insights. I didn't know this huge backstory of ELIZA, and it's although I didn't understand like anything about the code or something, you really presented it well. So to understand like how many varieties there are and developments over time of it and where it came from, thank you so much for showing us like what was also actually the big contribution that Weizenbaum took from the various already developments that were there before and brought them together. This was really helpful. I was like Magnus already said, I'm really interested to read a draft, like the finished manuscript, whatever. I'm looking very much forward to it. We would have like another break now. Let's say to stay in the time, 10 minutes this time. And we meet back at 7 CET here. And then with the last talk for today by Patrick. Yes, thank you again for the conversation, for the discussions.